The talk was called Emerging Best Practices about TypoScript. And the interesting thing is the part emerging, because that means they were not set in stone right from the start. You might know that TypoScript was part of Neos 1.0, and conceptually it didn't change that much since then. But we actually, we built a very versatile tool, but and we had some ideas what you can achieve with that tool, but we had not really a good idea like what people would actually build with it and what is feasible and what not. So that's why in the recent years, more and more people have played around with it, and some kind of best practices have emerged in the community, and of course also in the team, and we've talked a lot about them, and I just tried to wrap up some of these in this talk. So, but just to get you started and everybody on the same page. So you might wonder yourself, why do we need something like TypoScript? And the way I always think about it is that TypoScript is some kind of what I call a view coordinator. So it's something like something like the tower in an airport, for instance, which has the big overview, which knows exactly what's going on, which divides a big problem, the problem of managing an airport, into smaller problems in terms like making sure every airplane taxis correctly, every airplane can land correctly, can take off correctly, and these kind of things. So that means TypoScript is essentially the coordinator of the whole rendering process, and it is its job is to make the complex rendering of a big website easy by breaking it into small parts. Rendering the individual parts and then putting again together the pieces. So that's like the general idea. And if you remember my talk from yesterday with Christian, we talked about extensibility. And just a short recap, there were the two really big categories, planned and unplanned extensibility, where planned extensibility is actually supported for instance, during upgrades. Versus unplanned extensibility is basically you do it on your own risk, but it's some kind of escape hatch which avoids you that you need to patch the framework. And yesterday I said, yeah, let's move apart how this works in TypoScript, because TypoScript actually can do both. It can do both the planned extension and the unplanned extension. So I'm going to explain a little how that is meant to be in TypoScript and what the planned and unplanned extension points are. So let's talk about planned extensibility. And actually, there's one, TypoScript is based on these things called prototypes. We're going to talk about them in a bit. But they're essentially something like classes. And for planned extensibility, there's one extremely important prototype in TypoScript, which we call a case object. So if you know PHP, you know the switch statement. And actually, the case object is just like the switch statement, just implemented in TypoScript instead of PHP. So that means we have this case object on top, and it lists a number of variants, a number of different options. And each option has a condition when this certain option will be executed, which is called this condition. And then we have something to do when this condition matches, which is this line, which I won't explain in detail here. We will come to that in a later point as well. Actually, so that is like the default case in a switch statement, because the condition is always true, and it's at the end. It's located at the end of the switch statement. So that's pretty much like a switch statement. And a switch statement in TypoScript is basically, a point where the original author of the package, for instance, the original authors of Neos, the Neos team has decided that might be a really important point where you would need to hook into, where you might need to hook into, and where you want to change the behavior of the system. And the Neos content case TypoScript prototype is the one responsible for rendering each individual content element. So that means if you want to modify, for instance, if the headline is too long, you want to switch your template completely, that's the place you can do that globally in your whole instance, for instance. Right, so that's planned extensibility. It's just important because in TypoScript we can do both. It's just important that you remember, if you want to do planned extensibility, then look at the case objects available in the system, because they are essentially planned extension points. And for unplanned extensibility, that's basically everything else. So every line of TypoScript you write, except the ones with the case statement in, are more or less unplanned extensibility. So that kind of thing can be an unplanned extensibility. Don't look too closely. I could have written any line there. It's just what we do there basically is we override a certain part of TypoScript, of already existing TypoScript configuration with something else. And when you override something, there's one important thing to be aware of, which is the ordering of things to happen, right? So if I override, I don't know, let's say we have a tag, for instance, and this tag is called Neosourcecode, and then it's called inspiring con. And of course, the order matters a lot to what the tag will be evaluated in the end, because it matters which one overrides which one. So that means actually the loading order is extremely important. I hope that works now. Right, so that means we need to make sure that our custom TypoScript below is actually loaded after the standard TypoScript, which we want to override from above. So the above part is coming from the Neos node types package. Whoops, that was too fast. The Neos node types package, and the thing I want to override comes from my actual side package. And you might wonder how to do that, and we've come across that a little already. So that is handled during the package loading order in Flow. And you can control that using the composer.json file of each individual package. So that means you don't specify a big list like first load that, then that, then that, then that, but that is automatically done by the framework, by Composer. Instead, you just say, my side package depends on the node type package, for instance, and that way the system makes sure that your side package is loaded after the node types package, and thus can override the whole thing. Important, this is not the composer.json in the root of the project, it's the composer.json inside your individual package. That's very, very important to remember. And in case something goes wrong and you might wonder, oh, why isn't that applied? You might want to check the loading order of packages. And unfortunately, we don't have a command for that in Flow yet. I would really like that Flow package list would output the ordering of the packages, but it doesn't. It does it alphabetically. So currently, you need to do this little trick, looking into the configuration package states PHP, and then grab some lines out of that. And this is really the ordering of packages in which they are loaded by the framework. So that's just a workaround until we fix that in Flow. So, or if somebody would like to do that, he's really welcome. Right. So let's see next. So what I'm now going to do is I'll talk a little about different approaches, about different best practices. So we've been going through the basics now, and now we look at like best practices which have emerged. First, pretty easy, I think, files and folder structure. The only thing which I can say is basically you should use one TypoScript object per file, and subfolders should be done according to your domain. So really the subfolders depend a little on what you're building, so play around with that and do what makes sense for you. But I would really go for one TypoScript object per file because it makes the whole system a lot more manageable. Right, so that's about the file structure. I think that's pretty basic, pretty standard thing. So the second thing, which I think is a best practice and which we didn't see right as that and from the start, is that you should embrace TypoScript prototypes. And I would like to just show what a TypoScript prototype is. So essentially, you have the prototype definition, which says the slideshow extends from content, and then the instantiation is just, my slideshow equals slideshow. So in PHP code, just for an analogy, you can look at this. This is roughly corresponds to this PHP code. So that means we have inheritance, and we can create new objects from classes, and that's it. And you might wonder, why is that even important? Why is the concept of prototypes so important? Why can't I just copy things around? And for me, the main reason is actually giving things explicit names and thinking about these names, because this is actually where we do communication with other developers. So in the teams, or make sure, and this is how we make sure that we still understand the project if we revisit it a few months or weeks later. So that is often something I see in projects that people don't pay enough attention to names, and if they have come up with a bad name and then recognize it at some point, they don't change it. And I would really, really recommend that you know, if you start with a bad name, that's just normal, and if you come up with a better one, then just change it, but change it all the way through. Although that is some kind of effort, it is usually really, really worth it, and also in the sense for TypoScript prototypes. Right, so what we do if you do the Kickstarter, basically the TypoScript which is generated, which you modify, is this. We say page equals page. And if you have to do something like a special page, you basically copy this thing using this copy operator, and then you add a condition in this root case object where you say, under some condition, we'll just render special page instead of page. So actually, this code stems pretty much from so especially the first line stems pretty much from the roots of Neos, which is typo 3. So this is like why we did it that way. It was just because that was the entry point in typo 3. That was just basically the only reason back then. So, but that is something I would basically not recommend to do currently for bigger projects. I mean, for starting it's fine, but for bigger projects not. Instead, what I would suggest, is somehow this screen is a little laggy. Let's see, right. Instead, I would like to suggest something like this, which says, instead of creating the page right away and modifying the instance, we should rather create a new class, basically, create a new prototype, and then instantiate it here. Because that way, we can then at this point just extend from our basic object once more and then specify it or make it to a special point. And the good thing about this is that this is very independent of the loading order. So the left side is really error prone in terms of loading order, which means that if you change something on the page down here, this will not be picked up by the special page. And that's not usually what you want. Instead, if you change the page, you want it to be applied to everything which depends on it. So that's why we suggest the right way to do it as a suggested way. And it's also seen in many real-world projects, actually. Right. So, another interesting topic, which is composition versus inheritance. Sounds probably a little abstract. Who understands what that is? Okay, cool, a few, but then that means I can explain it, which is great. Who knows what inheritance is? Just cool, many people. Just to recap, inheritance basically means we extend from a certain object. So that means in TypoScript, it could be that we have a base object called myText, and we inherit from it, and we create my special text and myText with image, and we can override certain properties. And then you might have another base object called myImage, and now you might see the problem because myText with image actually inherits from my text, and you might wonder, why doesn't it inherit from my image? So somehow inherit both, or what do we do about that? And multiple inheritance is a very difficult beast, usually, especially in TypoScript as well, so it doesn't work. It is not implemented in many languages because it comes with a whole range of very, very difficult problems. It makes sense in certain use cases. For instance, for the node types, we have multiple inheritance mixins where it fits completely naturally, but in many domains, it's very difficult. So that means if we want to build myText with image with inheritance, we have to choose either to extend from image or extend from text. And basically, the decision which to take is pretty arbitrary. There's no, you can basically roll a dice and take either the one or the other. There's no thing to apply for that, and that's the problem. So let's look at composition. Let's see if that animation works, and that shows hopefully composition quite well. Right, so With composition, what you essentially do is you have a big thing, which is my text with image, and you compose it of smaller things. So that means you don't inherit from it and change something, but you instead pull in my image. You instantiate my image and my text inside the bigger component text with image. That means in this example, there is no inheritance at all. It's really just pulling in pieces, not inheriting anything. And I can just say, you should really try to use composition because it scales very well. It's really easy to grow through the project. You can start small, and then when the project grows, you can really compose from smaller to bigger pieces. It also fits very well with modern CSS and HTML standards or best practices like BEM or CSS modules. Or also the whole component-based ecosystem, like in React, for instance. So I can really say it's really worth to try to use composition for many, many cases. Except the inheritance feels so completely natural, then just do inheritance. It's not a one or either or the other decision. So you might wonder, how does that actually look like in TypoScript? Because I've currently didn't show any code yet. So let's see. Basically, what you do, you create your prototype, my text with image. It inherits from content, as it's just a normal content object. So that's just the basis, basically. And now, instead of having the image implicitly rendered somehow, you would rather create a new instance inside my text with image, which you call my image, or where you instantiate the object my image, and where you configure it the way you need it to be, so where you wire it to your nodes and these kind of things. And this way, in the template, you can just you will have just a very small template inside my text with image, which will say, okay, please place the rendered image here, please place the rendered text here, and that's basically it. So that's pretty nice for all kinds of things. And you basically do the same for the text element in here. So it's just I've just shown it for the image, but you can compose an arbitrary number of things together, and also in multiple levels, and that is pretty natural to work with. And as soon as you've gotten used to it, it's also very easy to do. Okay, who knows now what composition versus inheritance is? Just a quick. Some more, okay, thanks. Or you were very polite to me, which is also nice. So, cool. So, let's check something out. Let's see something else, which is from time to time you have your content not just rendered once, but multiple times. So we have the case that there's one content and there should be multiple output formats at the other side. And essentially, what you're doing there is, or if you look at the standard rendering, the standard content case, what you see there is that it means in all cases, render the node type's name as the TypoScript object. So that is basically inside Neos, this code, exactly this one. And this sets up the mapping. If you create a node with a certain name and you create a TypoScript object with the same name, that these are fit together. And so that is not hardwired in code somewhere in Neos buried, but it's really just a convention in TypoScript by this single line. So that's an extremely powerful line, which basically enables us to work the way we do. And we can adapt that. So that means, for instance, in the Flowpack search plugin, where we display search results, we have this kind of line where we say, okay, under some condition, we don't render the node type name, but we render the node type name and append the search result string. So that means just by doing that, a node like a product has not just one rendering in TypoScript, but two. So and with this code, it's not just it cannot be just rendered as a product, like in the page context, for instance, but also as a product search result in a search listing. And you can use that for all kinds of different, if you have content which is visible in many, many different forms, or if you have search results, if you have listings, this is usually a use case where this fits really, really well if you want to build such a package, or if you want to do that for yourself. Right. you see, the collection I'm doing is just, it's just many principles collected together, so don't worry that topics jump from time to time, but it's really a collection of things which I think are pretty worth talking about and which I think didn't talk about before a lot, so that's how I picked the selection. And so let's talk about Fluid versus TypoScript. Something many beginners struggle with is, beginners with Neos, is they know templating languages. They know something like Fluid. And they always wonder, well, I can do everything in my templating language. Why do I need something to learn something as strange, brackets and all that, as TypoScript? And the reason is essentially what I already said, that TypoScript is the rendering controller which makes extensibility possible. And versus Fluid is just really, if you don't want to extend it, Fluid is just a perfectly fine solution. And what I suggest is really it makes sense to learn TypoScript, and it is built in a really consistent fashion, which means if you've learned it once, the basic principles, you can apply them again and again and again. So that's really worth it. And if you do that, you can basically say, do the structuring and the composition in TypoScript and use Fluid just for very simple templates and basically just outputting simple elements. And I think a good rule of thumb is as soon as you use a loop in Fluid, usually you should rather do it in TypoScript. So that is like, I would say, a pretty 90% rule of thumb. As soon as you use a loop in Fluid, you should think about if you rather do it in TypoScript and gain that flexibility from that. And of course, no rule has no exceptions. So I think loops are perfectly fine, for instance, in a menu template. Because configuring something as complex as big menus just declaratively might be very complicated. And usually a menu is nothing you would like to extend, but you just build it the way it's meant to be. So that is something where I would say, okay, using inside the TypoScript, using inside Fluid a for loop for rendering the elements of a menu is a perfectly fine way to do that without any drawbacks, basically. Right. Now, we've seen some design patterns, and there's one topic I'm getting asked again and again when it comes to Fluid, the content cache. I would be really interested in who feels that he actually understands the Neos content cache. Could you just raise a hand? Okay, a few, some, okay, thanks. So I'm here to fix that. I mean, not understanding that, but rather I hope that everybody understands it afterwards in a better way. And I'll try to compose that in a smaller part. So that's like the second half of my presentation now. So essentially what we would like to do is pretty easy, right? We just want to cache a page. But when we, in order to, the page is built of smaller elements. It has menus, it has text, plugins, everything else on the page. So that means we also have to deal with these smaller parts. We have to deal with menus, with the text, the plugins, and the images, for instance, on the page. And these things form some kind of TypoScript tree. It's like a rendering tree. It's basically, in order to render the page, you first have to render the menu, then you render the content collection. In order to render the content collection, you first have to render the first text, then the plugin, and then the image. That's what basically this image says. So this is my example page on where I will demonstrate the different caching scenarios which are available. And essentially, the only thing we would like to say is, please cache the page, and that's it, and do the right thing. When we do that, essentially what happens internally is that every element of the TypoScript tree, now it works, has a caching property which defines how the caching works in detail. So that means caching is not just handled on the page level, but you can also handle it on the individual element level, and we will see in a second why this is important. So that basically means how does that work? By default, many things are, so there are three caching modes. One is cached, one is uncached, and one is embed. Don't worry, we'll come to that in a second. And basically, cache, of course, says, yeah, we want to cache that thing. And embed essentially says, I don't mind, of course, I want it to be cached, but I don't want to configure it explicitly. It's just one logical thing with the whole element I'm in. So that means if I do that and configure it this way, which is the default, there's just one big part, which is the page, which is cached, and the cache entry for the page contains the rendered menu, the rendered text, the rendered plugin, and the rendered image as an example. So that means that's actually pretty simple, right? This is how it's done in many other systems, which means we basically only cache at the page level. You know, we have an URL, we cache it, and render the whole thing, and that's it. So that is like the most simple case you can start with. So let's just see how this is configured in TypoScript internally, by default, by the way. You configure the caching behavior of TypoScript also in TypoScript. And this is done through this special property addCache, which you can add to any TypoScript object. And if you just specify mode cached, this is the way you say, please cache the whole thing. Right. So that's cached. And let's say the plugin we have put on there, you know, this element is not just a static thing, but for instance, it can, I don't know, it periodically pulls in data from another system. It shows the latest articles on BBC Newsweek, for instance. And of course, we don't want to cache that thing that often. We want to control more in detail how long things should live, right? So the whole page probably doesn't change that often. But the inner element, the plugin, changes very, very, very rapidly. And when the plugin changes, we don't want to rebuild the whole page because that can be very expensive. It can contain lots of elements. Instead, we would just like to be able to reload or recontrol the single plugin. And we do that by marking the plugin as cached again. And what we get out of that is essentially two records in the cache. The one is the page cache content, which contains the whole page, except this part. So that means the plugin, just instead of the plugin, there's just a marker which says, oh yeah, please pull that out of some other cache. That's basically it. And the plugin has a separate cache entry, and the cache entry, yeah, can live on its own, basically. Right. And from time to time, there are also things which change so extremely rapidly that the caching doesn't make sense at all, right? So if it's depending on the user or on the user's location, or I don't know, the exact time, these kind of things. There's also a third mode which we call uncached, which essentially means the whole page is cached. The plugin contains a placeholder, and on runtime, on every request, only this placeholder bit is filled with the actual logic of the plugin. So that's like the third mode we've seen. So let's step a little more into detail of that. So we have the three modes: cached, embedded, and uncached. Just to recap, cached means please store this thing in the cache. Embedded means don't store this thing specifically. Instead, store it as part of the outer cached element. And uncached means don't cache it at all. I think actually embedded is pretty easy. You know, that's just the default. Nothing needs to be done. We can tick that off. That is solved. So we have to focus on cached and uncached. And we'll now first look at uncached because it's easier to understand, and then finally we look at cached in order to understand the whole details there. So for the uncached version, let's say we want to render this page again, which you know, right? We have the page cached already. Now it comes to plugin. And in order to render this thing, we need some information. So the plugin has some configuration usually. This configuration resides on the node, so it's configured through the node properties usually. So that means we need to know, and every request, we need to know the exact configuration of the plugin at this particular point. And this boils down to the question, what is actually currently being rendered, and more technically speaking, it means what is actually currently in the TypoScript context to be rendered. And this is something we need to specify explicitly, meaning if we specify uncached elements, and these uncached elements, for instance, access the current node, which many, many elements do by default, to pull out configuration, for instance, we have to tell the system, okay, please make the node available as soon as you render the individual, the individual element on every request. So you have to specify this context variable, which means what should, and you just specify a list of strings, which are variable names, saying, okay, what should be available on every request in the TypoScript context for rendering. Right. So that is uncached. And now comes like I think the most complex one, the most difficult one, which is the cached part actually. And we have to get the whole picture, we have to check a little how caching works in general. So basically, what we do from the start, we want to cache something, and in order to do that, what we basically want to do is we want to skip some expensive computation, right? So rendering the whole page takes probably 10 seconds, but if it comes from the cache, it takes 100 milliseconds. So that means as soon as the page is rendered, we just want to redeliver it again and again. That's the basic principle. And the cache is just a big map. It's just a big array, basically, which contains all the data, the cache data. And every entry in this array has some kind of identifier. For instance, usually it's a page URL. That's just like the simplest way to do that. It's just, you put the page URL as cache identifier, use that, and then check, okay, is this page already cached? That's the second box up here. If no, we do the expensive calculation, we render the page, then we store it in the cache, and on the second request, well, we just deliver the page cache record. And that's also that's basically it. That means in Neos, what you can do, you can specify how this entry identifier is calculated in detail, which means you have a very fine-grained control about what is stored in the cache and what not. It's not just automatically done on the URL basis, that's just the default, but you can also configure it for more advanced scenarios. So, for example, you could say the entry identifier should contain the current node, which is in the URL, which is basically the current node. And then you could also say it depends on the current preview mode. And the current edited preview mode in Neos is not part of the URL. This is just part of some setting basically available. So you could say, I want to make the current cookie or the current user's location part of the cache entry identifier, and this way control in a very fine-grained manner what is basically cached and what not. So what you could also do, by the way, just to highlight that and to show it in detail, you could also use a static fixed string as entry identifier. That doesn't really make sense because it actually means that all pages will have the same content, right? Because all pages are just stored in the entry identifier hello world. That means the first page I visit is the one stored in the cache, and every other page I visit will output the content of the first page. So not really usable, but I think it serves well to demonstrate the principles behind the caching. So we are done, right? Well, it turns out not really. There's, from a very clever guy, a nice quote which says, there are only two hard things in computer science, cache invalidation and naming things. Oh my god. So cache invalidation sounds pretty ugly. So as soon as the content does not change, cache invalidation is no problem at all, right? So the problem is because our content changes from time to time. These editors, they're writing things, and if they do, they want it to appear on the website. And this is the difficult part. So that means the core question we need to solve is, when should a cache be flushed? So empty the cache again so that it gets rebuilt on the next request. And I think that is the most difficult part in Neos, basically, or the most difficult part about caching in general. I'll try to explain it, although it's conceptually easy, but it's pretty difficult to wrap your head around from time to time, also for me personally sometimes. So every cache entry has what we call certain tags. A tag is just an identifier we put on the cache entry. And the caching system allows us to flush everything which has a certain tag annotated on it. So that means we can basically say, please flush this page cache if anything changes, or please flush this page record if a certain node changes, as an example. And what we do is we put these tags on the cache record when we put the things into the cache. That's the first part. That's this thing here. And the other thing is, if something changes in Neos, then certain events basically are emitted to the system, which means on any change, this everything event is triggered. When a certain node changes, this node with the node ID is triggered. And also the event of all the parent nodes with the descendant, and also of the current node type. I know it sounds kind of crazy, but that way you can essentially configure on a very fine-grained level, say, okay, a certain content element should be changed, but whenever I change anything in the system, then you would just take it with everything, and then it would be flushed every time. If you just take it with the current node, which is the default for many things, it means as soon as the current node changes, we flush this entry. Descended of is very helpful for stuff like menus to be recalculated and these kind of things. And node type essentially means, let's say, as soon as one page changes, a page title changes, let's say that, I have to flush certain elements which show these pages. So that means they have to depend on this node type so that they can reflect it correctly. So I hope I got everybody confused. Well, no, not really. I mean, the thing is, it's just the really difficult part to understand, or the most difficult part to understand. And I think the problem is that we don't really have tools to visualize that yet. So that is something we have on the radar, we would like to do, but it's nothing which is currently in the system. The good thing is, Neos has sane defaults. That means don't worry too much about that. Usually in Neos, things go pretty well in terms of caching. That means everything is basically cached, the cache identifiers are configured correctly, the flushing works for the standard elements correctly. If you build normal content elements, they are also just normally flushed. So only in special cases you have to deal with that in detail. And actually, the documentation is pretty good. It tries to sum up the different parts, and I hope that, you know, with the talk I've been giving now and the documentation, you will be able to figure it out a lot easier the next time you run into these kind of problems. That is like the hope I'm having. So that's it about caching. It's always cool to look at other packages, check what other people are doing. And so I wanted to highlight some existing packages which I think which are really cool and well done. And the list is not complete. But I would just like to highlight them and recommend to look at them and be inspired by them. The first is the Listicle package made by Dimitri. It has a great documentation. It is built in a very understandable fashion, I think. So that's just, if you need to list something with pagination and these kind of things, please look at that package, check if that solves your problem. The second package I would like to highlight is the Neos Marketplace package, which renders the package listing on neos.io. Because it has a very big structure. So you see, this is all TypoScript files on the left. So that's a pretty advanced project. And this advanced TypoScript is not just used for rendering things, but also for building up queries, for example. I would like to recommend to you to look at neos.neos.io. I mean, we have published that as well during the launch. That means on GitHub, this package for the current website is open source as well. You can just look at the source code. You can even fix things, do a pull request if you like that, and we would like that a lot. And I think it is also structured in a pretty good way, meaning just have a look at that and see if that fits for you. That again, this URL is from the work of Dimitri. And they, as Dimitri already explained, they have this open by default policy. And they have quite some interesting gems to look at. Pretty small projects, pretty big projects on both sides. So that is really what I can recommend to look at that and these things. Right, and then finally, look at Neos, the source code of Neos. Look at the Neos node types by default. They are not that difficult to understand. And if you have questions and don't understand things, let us know. We are really keen on improving documentation also in the code and these things. So please just look in there. Tell us if things go wrong or not. Just let us know. To sum it up, for this part, I would really like to encourage you to experiment a little, to share your results, to discuss them with us and in the community, and then to iterate and publish these packages. And let's see what we come up in terms of best practices, in terms of how we build websites and web applications with TypoScript in the future. So, thanks a lot.
Thank you. Thank you very much.